So where we left off, we had written a function to get the smallest value from our tree, and we were to implement delete. I have also pondered on when it's good to add more than one dimension to make certain choices more obvious. For example, when you delete in a binary tree, you have some tricks you can use which you can't use in a KD tree because of the layer of access. Maybe we should add that beforehand. Promote action before pondering. I'll just continue here, and then maybe we'll change our mind and redo it the other way around. But I'm gonna describe delete and first test is test can't delete something that isn't there. It's not. I don't know how to write that correctly. Let's just do that. And so given a empty tree, let's delete one, and it should equal empty. I can write it correctly. Okay, so delete here does not exist yet. So let's go to sibling smallest and add delete. And delete here takes a k and tree of k and returns a tree of k. And this should make it pass. It doesn't, because this is not exposed and this is not included. And now it passes. Okay, so what is the harder test that the code does not support? Test it does not remove item that don't match the given key. And this is misspelled, change to that. So giving a singleton of 1 and we delete 2, it should equal singleton 1, and we need to put parentheses. That was what we expected. So let's take the tree. We now know that we don't use the first value here. Let's write a task that forces us to use that value. Let's do tests. It moves the value if it's the only value. It seems like there should be a better name for this, but let's continue. And we have singleton one, and we delete one, then we should equal empty. So case tree empty is the one we know, and then the other one we can ignore these, and let's just turn tree to see that it goes through. So now we do a case, we do a if k is smaller than k1, I really need to do this, then equals 2. See? Good to always check. I was about to implement more than I need. Let's see. Okay. So obviously here we're not using smaller and larger tree here. We are also not checking if k and k1, if it's different, if it should be smaller or larger. So let's first refactor this, because we can do a case of compare with k and k1, and if it's equal, then do empty, else do tree, right? And now we get this type error that this needs to be comparable. So we can copy that, or we can ask editor to fill it in for us. And now it should compile. Right, okay. So we can now do a test. It removes t from smaller sub tree if it is smaller. So how is this scenario? How does this look like? So we need to have a tree that has more than one level. So let's do first node, and we can have a singleton one there, and I can't spell, so let's click the editor, and we'll have a number 2, and then we'll have an empty, and we do delete 1, and then we should have equal singleton 2, right? I think that's correct. And they want, of course, parentheses. Yeah. So it's less than or greater than. So this is basically the same thing as before. We have a we know that this is the case, that k is less than k1. So then we want to do node k1 and larger. Here should be delete k from smaller, and we need to add smaller and larger. Okay, let's do the same thing here, but do for larger. We do you can see here that I'm both a slow and a sloppy typist. Okay. So this should pass. So what are we missing? Haven't we done everything? Well, if they are equal, we now only do empty, which is not true for all cases. So it replaces root element with smaller. So say that we are deleting 2 here. We would like to have that one. So node, we want to have delete small from smaller, and we want here to have small and larger, and let small be smallest in smaller. So here they say, maybe smaller doesn't exist. which is totally true, it might not exist. It would mean that this branch is empty. So we could either try and check the result, which I feel is okay, or we could see if smaller is empty. So let's do one more case. Smallest on smaller. Wait, we need to do this on the larger, right? Let's undo all this and fix the test first, because the test is broken, not the code. So replace root limit with smaller from larger. So it's actually correct that it should be empty. And this should be singleton 3. I think they'll fix the parentheses. This should be like that. Okay. So we'll still use what we learned from first try. So case smallest of larger. Oh no, that was the wrong format. There's the right format. Okay. So before we did just empty, right? Let's add that. So we know this time that we have something larger. So let's fix this one. Node smaller, and then we have a, and then we have delete a larger. So now I have this that we know is not correct. So say that there exists no larger branch. It replaces root element with smaller branch if larger is empty. Is it complaining? I'm just going to say smaller, right? Because the error was on a different line. And now the panic because I changed the code. Let's just make sure that I didn't do anything. So this was the original code, it failed, right? Yes. And then smaller. And I'm quite sure that we're missing some tests, but I feel quite confident that this is correct. And that if I feel like I have a bug, I will be able to add more tests. So I would feel this okay. So this is enough for this video, and I hope I'll see you in the next one. Bye.